So thank you guys so much for coming out. It's good to see some familiar faces, some new faces as well. For those of you who don't know, my name is Aleksander. I'm the Executive Director of the Chicago Blockchain Center. We're a nonprofit that is starting to be an educational resource, community aggregator, and ecosystem developer for the Chicago-based cryptocurrency and blockchain community. So we do several events like this a year, a couple times a month as well. This is a continuation of our Startup Spotlight series, where we like to highlight various startup efforts that have some kind of a Chicago presence, whether it be an ambassador or a co-founder or are headquartered here, that are doing really interesting things in this space. So today we have the distinct pleasure of hearing from bloXroute. So first what we're going to do is a presentation by Soumya, the CTO of bloXroute, and then a question and answer session at the end. So without further ado, Soumya, take it away.
It's great to see everyone here. Hi, I'm Soumya, CTO of bloXroute Labs, and I'm here to tell you about the network for tomorrow's blockchain. So first let's take a step back and talk about what is blockchain. And blockchain really is about taking traditionally centralized systems and making them more decentralized. And by centralized, I really mean from a point of trust. So if we look at the US dollar, for example, it's backed by the US government. You need to have some faith in the government here. And in a decentralized setting, you trust miners, right? A group of miners. In a centralized setting, you can run your code on AWS and hope that they don't censor or they still like you after you run it there. And in a decentralized setting, you can run your code on Ethereum or Tezos, and that's more uncensorable than something on AWS. So a lot of people say blockchain is trustless, and that's not really true. It's distributing the trust. So if we look at, for example, in Bitcoin Cash, it assumes that most of the CPU power that is used in mining is honest and will do the right thing. Now if you look at this protocol, which is a 20-year-old protocol called PBFT, it's used in permission blockchains. PBFT assumes that most of the named parties are honest, and that they will do the right thing. So when you run your blockchain protocol, you end up with a state. So for example, in Bitcoin Cash, you could have, say, the four bloXroute, the co-founders each having an account balance of 2 BCH. Now, if Uri wants to pay me 1 Bitcoin Cash, what will happen is everyone will update Uri's balance to 1 Bitcoin, and they will update my balance to 3 Bitcoin. And that's how payments work in the Bitcoin ecosystem. So the question here is, where does bloXroute fit in all of this? And the idea is that before you agree on a state, before all of these trusted entities can agree on a state, they must first know what that state is. And that they do using some kind of network. And bloXroute wants to be the global distribution network that transfers state among these untrusted parties very, very, very quickly. So if we look at Bitcoin mining in a little more detail, we can see what happens when the network actually is slow. So you have the global view of the network, which has the 3 blocks, and right now everything is nice and working fine. So the miner also has the same global view, and this miner 2 also has the same global view. Now, at some point, miner 1 will mine a block, and they will want to append a block to this global view. And later, if the network lag is really, really long, or long enough, miner 2 will mine a block at the same height. Because they're all trying to extend the longest chain that they know of, miner 2 will actually mine on top of an old chain. So they'll produce a competing block. So this is what's called a fork. Now, eventually, some fork will get mined. So some block will get mined on top of one of these forks. And that's a chain that's going to end up winning. So at the end of the day, you have a chain of 5 blocks that all 3 groups agree on, but you have this poor miner's block, miner 2, that didn't get included. So why is this bad? This is bad for 2 reasons. The first is that miner 2 in this block had sequenced some transactions. These transactions don't make it on the chain, so you actually lose a little bit of performance here. Additionally, the miner spent some hash power trying to solve this block. And including this in the chain would make that chain more secure. So you actually lose some security and performance by having these blocks approved. Okay. Now, the scalability problem you can actually see in these 2 graphs. So so there's a measurement study done, and on the y-axis here we have the mining power utilization, which basically is just a fancy way of saying when you mine a block, how likely is it to make it on the chain? And now Bitcoin runs at a very slow 3 transactions per second for the duration of the study, and you see that when you go when a miner mines a block, they're able to get it on the chain with over 99% probability. Now, if you go from 3 to just 12, which is Ethereum, you see this probability drops quite a bit. So you only have a 92 to 94% chance of making it on the main chain if you mine a block on Ethereum. Now, when we're talking about scalability, we're not really talking about 3 transactions per second or 12 transactions per second. To talk about real scalability, it's thousands, right? If Visa does 2,000 transactions per second. So when you want to push this to that level of scale, these probabilities drop quite a bit. So most of the hash power that miners are using won't even make it on the chain. And the chain will actually not have that much throughput, even though a lot of transactions are being put into blocks. So we take a deeper look at why this is happening. So, the animation worked. So we have the giant network, and some miner mine a block. They slowly start feeding it out to their neighbors, and then eventually, slowly, the neighbors will receive that block, and they will start propagating it to their neighbors. And they have to wait for the full block before they start sending it on, because remember, this is untrusted. You can't trust that this miner is actually sending you a good block. So you need to validate it before moving on. So basically, the block propagation over this peer-to-peer network is pretty slow, right? So one simple solution to this problem is we use a fast network. So what if we just use AWS, right? So we get rid of that problem where the blocks now propagate very, very quickly because AWS is a pretty optimized network. But if AWS, say, doesn't like a transaction for whatever reason, it can decide, I'm not going to propagate this block because it contains a transaction I don't like. Suppose it's paying one of its competitors. So this is an easy way to actually rebuild the thing that we were trying to avoid building in the first place. We just built a new centralized system. Instead of the nodes being centralized, we just centralized the network. So we kind of lost the point if we did this. So the bloXroute trick is to get the performance of something like AWS without actually putting any trust in it. And we do this by putting a box around the bloXroute network and having a provably neutral API. And what does that mean? That means the peer-to-peer network still exists, and it exists solely to check whether bloXroute is actually propagating the blockchain transactions correctly. So the peer-to-peer network is not doing much work at all, and bloXroute is really doing most of the heavy lifting for propagating transactions and blocks very quickly. And this also means that if bloXroute ever decides to misbehave, ever decides to censor some block, the peers can detect it and just stop using bloXroute automatically. So there's a question here of how do we make it faster? So we have the same network as before, but we have some bloXroute servers. So here again, we have the miner that found a block. But first note that the block was made smaller. So we have end-to-end compression. So the actual data that you're sending is smaller. And additionally, we use cut-through routing. So the bloXroute server just propagates the block forward immediately as it receives these packets. But the animation is kind of fast, so wait 1 second, sorry. So yeah, this goes by pretty fast. But yeah, so we saw the compression again. And then when you see it propagates it to its peers, its other peers will do what they were doing before, but the bloXroute server will start forwarding immediately. So what actually ends up happening is a lot more peers receive it at the same time. So the interesting part here is that the bloXroute internal implementation doesn't matter because we put a box around it and had a provably neutral API. So we can actually just sit there making bloXroute faster and faster and faster, while all the blockchain nodes will see is just the network getting more and more and more performant. And we can actually use every network optimization trick in the book. We have lots of networking research to go off of, and the experts needed to leverage it. But just the two tricks that I talked about earlier, compression and cut-through routing, are sufficient to get you to thousands of transactions per second today. And what this fundamentally does is it closes the gap between these decentralized systems, which are running at 312 transactions per second, to centralized systems like PISA. So there's now so we can run these decentralized systems at scale. Speaking of decentralization, bloXroute can also help with that. Bitcoin and Ethereum are controlled by about 20 miners. They control almost 100% of the hash power. There are many reasons for this, but let me just posit one more. Having many, many miners, we have thousands of miners that were distributed all across the world. This is actually very complicated to organize and optimize at the network layer. Right? There's lots of crazy things that happen on the private area. One way to solve this and make this complicated networking problem more tractable is just decrease the number of miners, or centralizing mining more. And this actually fundamentally compromises, again, the whole premise and the promise of blockchain. So bloXroute here offers another solution, where we manage the network and make it so that all of those complexities are hidden away from the end blockchain. And another thing is, we actually see a lot of chains starting to attack the network problem. In particular, Bitcoin has made a lot of progress in the last few years. So it's looked at XBIN blocks, compact blocks with graphene, as well as a centralized relay network such as Falcon. The bloXroute composes well with these efforts, but every single blockchain, as they sort of get more and more usage, will have to resolve all of these problems. But Another way to do this is to just use bloXroute. It's one solution that works with all blockchains. So, additionally, remember, we put an API around bloXroute, which means as bloXroute starts optimizing the network, it actually will speed up the network for every blockchain instead of just one or two, instead of doing this one at a time. So this way, this actually lets blockchains compete on features and other things that they can do instead of just can I use a chain and will putting a cat application on it would make it completely unusable. So taking a look back, Bitcoin and Ethereum were game changers, right? They really showed us that there is a demand and an interest in having global decentralized systems. So as I talked about before, Bitcoin was money, and Ethereum was trying to decentralize something like AWS. But they were really just the first generation of blockchain networks. There's a lot of cool new ideas coming out. So some things you may have heard of: proof of stake, on-chain governance, privacy-preserving cryptocurrencies. And this really isn't scratching the surface of the innovation coming out of this space. However, all of these changes, all of these improvements will have one fundamental problem, which is the networking problem. They will all need to figure out how do we communicate with each other so that we can agree on a state. And when they run into that problem, the bloXroute will be ready to step in and solve it. Thank you very much. I'll now take any questions. Please follow us on Twitter if you're interested. And we are hiring, so if you're interested to sign up. Thank you. Yeah, go ahead.
It's very cool, exciting. If I understand it correctly, the way that your innovation gets out into the world is miners agree to send their, connect with your API. How do you get adoption? Who do you need to make a choice to have to use blockchain?
Yeah, so we're actually fairly well incentivized. I think all parties are incentivized to use bloXroute. So, so as you correctly mentioned, a miner is incentivized because they want to hear of the latest blocks, right? So miner 2 doesn't want to be mining on an old chain because they could be wasting their hash power if they get unlucky. They want to be mining on the most current state of the chain at all times. If bloXroute is the best way to get it, then miners will go ahead and use bloXroute. Now, if you're looking at it from the user's point of view, a user will use bloXroute to submit their transactions to the miners, right? They want to get their transactions to the miners as quickly as possible as well. And actually, the Falcon relay network that we mentioned is actually something that was built by 2 of the bloXroute co-founders. And actually, we saw a lot of use from wallets that connected to Falcon to send transactions through it. So it wasn't just blocks.
This might be my own ignorance, but what's a user?
A user I define as anyone wanting to send a transaction that is not doing any mining.